the first thing we want to do is basically give a sort of quick demo over the sort of core functionality of ScriptRunner for Bitbucket. I know some of you might be evaluating the product and not be that familiar with it, so I think this is an opportunity really to sort of showcase what you can do with the product outside of the box as soon as you install it. So the first thing to think about is that ScriptRunner for Bitbucket is a complete tool set. You can customize, automate and extend Bitbucket workflows however you want with the tool, and you don't have to worry about creating your own app. So that's really the beauty of the product. It allows you to enhance standards, enforce standards rather for security and data compliance, which is particularly important if you're in a regulated environment. And I believe some of you are likely to be working in regulated environments on the call. And you can customize the UI, and we've got some demos coming up that will show you how to do that later on in the talk. And you can also do some backup and disaster recovery using the mirroring services and create some smart reports. And again, we've got some questions about that coming up later. The product, when you first install it, has got over 40 sort of built-in scripts, jobs, event listeners, pre and post hooks and merge checks, which allow you to do a whole range of customizations with the product, which we're about to sort of show you. But the first thing to talk about, I think, is really that when you install the product, is really to sort of think about how you can use the product to make safer workflows when you're using Bitbucket. And what I want to show you is the recommendations that we put together to get really the best out of the product when you first install it. And I think the first thing to think about when you're thinking about your Bitbucket workflows is really to place security at the heart of your workflows. So you can do that in a number of ways using a number of hooks and built-in scripts using ScriptRunner. So the first thing you can think about is setting up some default project and repository permissions. So this means that from the outset of using the product, you can always trust that your projects and repositories have the permissions that you want to specify at a global level. You can also enforce trusted commit authors. So this means that every commit that's committed to your push to your instance, is by a trusted author. So again, this is particularly useful if you're in a regulated environment and you have to know where every commit's come from, and basically trace that audit. You can also set up mandatory reviewers and even a minimum number of reviewers. So again, the importance of this is that if you've got sensitive code and you need particular individuals to review that code, such as security experts, you can actually specify that they are mandatory reviewers, and you can also specify a minimum number of reviewers. So for example, that all code changes require at least two developers to review them, for example. And finally, when thinking about security, you can also set up the automation of withdrawing approvals on when a pull request has changed. So this makes sure, for example, that no code goes, creeps in through the cracks. So if a pull request gets changed because there's some comments that mean that code needs to change and you commit to added, the reviewers that originally approved that, that pull request, their approvals are withdrawn. The next thing to think about when setting up your workflow in Bitbucket is to think about an audit trail. Again, this is important if you're working in a regulated environment and you have to be able to trace back where, what decisions were made, where code was attached to a JIRA issue, say. And the three things that you can do in Bitbucket out of the box with this is you can enforce project and repository naming standards. So you can set up to say is that all projects and repositories must follow a certain naming pattern, and you know that from the outset, setting that up, and you can apply that across your entire instance. You can also do this for the branch and tags as well. This is particularly useful for naming and standard enforcement for branches, because you can, for example, specify that every branch must include a JIRA issue key in its name. And finally, you can require all commits to be associated with JIRA issues. So again, with that traceability, it means that you can basically look back through your commit history and always know which JIRA issue that commit was associated with. And finally, the last thing to think about when setting up your Bitbucket instance using ScriptRunner is to think about how you can further avoid future security risks. And you can use a couple of tools we've got inside ScriptRunner for Bitbucket out of the box, which the first one is you can schedule an automated job that will basically deactivate users at the time they should be deactivated. So this means that at a point a user shouldn't have access to the system, they won't have access to the system. So that's one way of enforcing security. which I'll show you later on. And then a relatively new script that we've added is that if you have users that have been deleted from your Bitbucket instance, they might still, for example, have some old artifacts lying around, such as personal repositories. We have a new built-in script that allows you to basically view any orphaned personal repositories and then delete them if necessary for users that no longer exist. And again, I'll just show you that as well. So without further ado, I'll now move on to sort of demoing some of these sort of scripts that are in a test instance of ours. So this is my Bitbucket test instance. So as you can see, I've got a sort of test instance set up here. So if I go to the admin section, you can see I've got ScriptRunner already installed in the instance. And the first thing I'm going to show you is the event handlers that I've already specified and set up for this demo. So the first one I've set up is the default project permissions. If I go in and edit it, you can see that what I've set up here is to say that all projects that are created will have a read access for all users by default. But I've also said that I wish for the admin user to have admin access and any users inside the stash users group, in this example, to have write access. And again, here I've done the same with repository permissions. So again, you can specify for all repositories that are created that in this case, the admin user will be an admin and any users in stash users will have write access. The next event handlers I've set up that are listening to events is the auto adding of reviewers to pull requests. So in this case, I've set it up, and when you set up hooks and event handlers inside Bitbucket, for those that are not currently familiar with this, you can specify which repositories you want to specify the event handler for. In this case, I'm saying I want all current and future repositories, this to act on all future and current repositories when pull requests are created. And in this case, I've said I wish for the admin and reviewer users to be classified as basically added as mandatory reviewers on every pull request that's created. And the next event handler is to withdraw approvals on a pull request. So this one, again, is basically being specified to run for all current and future repositories, as all the examples are in my demo. What you also notice here is a lot of the built-in event handlers and pre-hooks, etc., have a conditions field. When the condition is blank, which it is for the case of for this demo, it means it will run all the time. But you can, for example, there's some example snippets here that say, for example, you would only want it to run if, for example, some C++ files have been changed inside the code commits. But by leaving it blank means I wish this hook to run every time.
Robert.
Yes.
So far in the events that we've looked at, there's no code going on. Is that you've set the event, you've told it what you want to include, and it just does its thing, yeah?
Yeah, so all of these are built-in scripts, yeah. So you can create, so what I've done here is you can see here all of the built-in events we've got. So for example, auto-adding reviewers, automatically configuring the delete branch checkbox is another example. Here you've got your default project and permissions and naming standard enforcement. But you could, for example, create a custom event handler. If I was to go and create a custom event handler, you could then write your own custom inline script. We do, so later on we will have some examples of that, creating some custom stuff based on some of the questions that have already been submitted.
Cool. Thanks, Robert. I just wanted to point out that the built-in scripts are powerful, quite powerful, and involve very little button pressing to get a lot of valuable work done quickly. Thanks.
Yeah, so so everything that I'm demoing in terms of what you can get straight out of the box. So this is literally as you install ScriptRunner, and I talked about, thinking about security, placing that at the heart of your workflow, your audit trail, all those tasks are built-in scripts. So you don't need to necessarily know any coding knowledge in order to take advantage of them. You can take advantage of them the moment you install the product.
Which is not to say that people on today's webinar are not already familiar with coding. I don't want to discourage anyone from writing code. It's just we've done a lot of legwork for some important features right off the bat. Thanks, Robert. Go ahead.
Cool. Yeah, and I guess the last event handler I've set up here is the naming standard enforcement, which for projects and repositories is very simple. I'm basically saying any upper or lowercase letters, but in the real world, you could have all sorts of regular expressions that you want to basically use to add, you know, to enforce whatever naming standard you might have. And then moving on to the pre-hooks. The pre-hooks will operate when a commit is made. So basically they'll check to see if a commit should be made, for those that are not familiar with pre-hooks already. So the main ones here are basically enforcing trusted commit authors. So this, for example, will basically it's configured again for all current and future repositories, basically checks to see, is the user making the commit, or do they actually have right access to the repository? So then it will basically enforce that and stop the commit from being pushed to the instance if they don't. So this is useful, for example, if a committer is trying to commit a commit of another author, so they might be trying to commit from another author who doesn't have access, and then someone else is committing for them. It's basically checking that the original author of the commit does have right access to the repository. And again, next couple of ones on here are naming standards. So this one here checks for the naming standards of branches and tags. And so, for example, here I've set up that a branch either has to be a feature or hotfix, named feature or hotfix. And in the feature example, I've also set up a regex, which means that regex matches to, for example, a JIRA issue key. So again, you can then have the mapping where the branch is always referencing a JIRA issue key and enforcing that. And by leaving the message blank, the default message is basically to highlight to the user what the regex pattern is that they need to name their branches for. But you could write your own custom message. And the final pre-hook I've set up is to require every commit to be associated with a JIRA issue. So in this case, set it up for all current and future repositories. And I say I'm going to search for issues inside it. I've got a linked JIRA issue application set up, and I'm basically searching all issues in this example that have a status of in progress. But in your particular needs, you might choose another JQL search that you're going to search for the issues that you're interested in checking. And there's a couple of checkboxes here that then say, for example, I want to exclude merge checks, and I want to check every single commit, not just one of the commits inside the push. And finally, the merge check that I've set up, which I mentioned previously in the slides, is to say I want a minimum number of approvers. And in this case, as I said, is 2. So every line of code is then checked by at least, you know, when a pull request is opened, you have to have at least 2 reviewers before you can merge in that pull request. So this then means that every line of code that's reviewed as part of your development process is reviewed by at least 2 developers. So with that said, I'm now going to sort of show you how some of these, now I've set up these hooks, and this is the administrative section of Bitbucket. Now I'm going to show you how some of them are actually used in, you know, in person, as it were, or while you're using your development. So if I go to projects, for example, and click on create project, if I was to write a nonsense project name like this, which no one should really, you know, really want in their instance, and click create project, you can see, or should have seen, that it came back with a name. It should have come back with the event handler. It should have come back with a, so it should have come back with this, but there seems to be a technical issue with that one. Oh, there we go. It's because I didn't type in the key at the same time. But what it would have done is, so it's coming up with another error. So when I did type in the key, so what it's come back with is to say the regular expression, it must basically be lower or uppercase letters. So now, if I basically make a non-nonsense real project name, it now creates the project. And when I go to create the repository, again, if I give it a nonsense name, again, it's coming back and saying, no, you must basically create it with lower uppercase letters. So now going forward and using a test repository that I've set up, what I'm going to do is show you some of the, basically the pre-hooks that will basically what the end user developer would see, that some of you may not be familiar with. So if I basically now try to create a new branch, so some of you may already notice that I've typed in new branch as the branch name, which I'm anticipating isn't going to work because that doesn't follow what we previously discussed about branch names having to be called feature / Jira issue name. And if I also now add a file, which I'm going to commit, but what I'm going to do is basically commit it as an invalid user. And the reason why I'm doing this is to show you what happens if the basically an invalid user who doesn't have access to Bitbucket, why it won't allow you to commit that for that user. And I'm also going to basically add an invalid message. So an invalid message is one where it's not referencing the Jira issue in this case. So now if I try and push, so now you can see that this is now ScriptRunner for Bitbucket working, and you can see the first thing it's told you, which is preventing the commits from being pushed, is to say that the branch name new branch doesn't match the required naming pattern. In this case, for example, being feature / the regex, and the regex being compatible with a Jira issue key. So the first thing I need to do is basically now rechange my branch name before the commit can happen, or push can happen rather.
Robert, while you're typing, I'm just going to point out that there was an interesting chat in the chat and around project level configuration. And Reese has included a link in our chat. If project level configuration is something you on the call are interested in, there is a link that Reese has provided. Please let us know. Vote.
Cool.
Thanks, Robert. Go ahead.
Nice. So now I've renamed the branch. Hopefully now if I now push again, it will come back and say, but it won't report the error with the branch name, hopefully. But what it should do now is basically now it's reporting 2 new errors. So this time it's stopping because the commit message didn't reference any Jira issue, and that's a requirement that we set up. And it also is basically saying that the user invalid user doesn't have right access repository. So again, it's not allowing me to make that commit. So the first thing I'm going to do is change the user of the commit. And this time I'm going to basically make the commit myself because I do have access to the the Bitbucket instance. I'm not going to change the message just yet to show you what should happen. And now if I push, you can see that now it's not complaining that I'm an invalid user. So it now believes I am a valid user trying to make the push, but it is still saying that the commit is not associated with any valid Jira ticket. So again, what I'll do is I will amend the commit. And this time I will change the commit message so it is associated with a Jira issue. So here you can say JRR-1 is my name of my example Jira issue. So that's now the new message. And if I now push that commit, you can now see that the push has come back and no warning message has come back. And in fact, now if I go to Bitbucket, you can see that the new branch has been created. If I click into the branch, you can now see the commit has been made, and also that commit is associated with a due issue. So you've got all of that, basically that auditing in place. And also the security worked kind of when I was trying to make the push, and now you've got the auditing here. And the next thing to look at is if I now want to create this, so I've made this change and I now want to create a pull request. So when I create the pull request, the first thing you'll notice is that the reviewers, admin and reviewer, have been added, and they've got padlock symbols, which means that they're required. And so again, this is what we set up when we said is we wanted admin user and reviewer user to be added as mandatory reviewers. And I'll now create a pull request. And this is created pull request. And again, the first thing you'll notice here is a warning, and the warning message is basically saying you still need 2 approvers before this pull request can be merged. So again, that was when we set up the minimum number of reviewers. So we always say we need 2 reviewers to approve the pull request. But first of all, what I'm going to show you is I'm going to sign in as the admin user and approve the pull request. So you can see I'm now signed in as the admin user. I've got the open pull request, which I'm now going to approve. And that's now approved, and the message has basically been updated to say you still need 1 approval before the pull request can be merged. But what happens if, for example, I make another commit? So let me add a second file. This time I'm just going to shortcut and do everything properly, so I won't get any error messages. So I'm giving it a proper commit message. And this time, if I click on commits for the pull request, you can see the second commit's been made. And now if I go to the error message, it's still saying 1 made. But also you can see that basically it's also saying that the admin user is unapproved. And they are unticked now, and they're unapproved. And actually it's saying that two approvers are still needed. So it unapproved the moment I made that second commit. So that is showing the development workflow. The final thing I'm going to show is that after a while, you might have some things that you want to tidy up. So this is really the third section of the slides I showed about what you can do to keep your instance in a tidy format. So what you can do is you can go to script jobs, and we have some built-in script jobs. You can, again, make custom scheduled jobs if you want to do some inline coding. So there's an inline coding box that allows you to write your own custom scripts. But the one we do have that's built in is to deactivate users. And one here I've set up is to say I want the user Robert to be deactivated on the 1st of July. But what's also nice about it is I can actually also run that now straight away, which is good for the purposes of the demo, to say I want the user Robert to be deactivated. So I can run that now, and it says the user Robert has been deactivated. And if I go to the users section of Bitbucket, click on the user Robert, you can now see he's unlicensed. And then let's say I completely delete the user Robert from the instance altogether. So now deleting the user Robert, completely removed from the instance altogether, but the user Robert had his own personal repository, but that's now kind of hanging around. That's kind of dead in the system, and there's not an easy way to clean it up. But what we recently added was a built-in script, and where built-in scripts are basically sort of one-time tasks that you can run. So you can do things like viewing repository size reports, but in this case, I can go and view and delete orphan personal repositories. So if I preview this, you can see that there is still, for the owner, R. Giddings, who is Robert, who is the user I deleted from the instance. It says Rob's personal repository. When I click on that, you can see that exists. It's just an empty repository at the moment. But what I can do is I can say, right, I want to do a cleanup. So I can delete the orphan repository, click run. And now it's telling me it's deleted the repository. When I click on this, I can confirm the repository has been removed. It no longer exists. So that is the end of the demonstration.